Okay, the first two rows. First row, total fish caught, number of boats here. Right. Now total revenue is going to be the same number because we made the example very simple. The market value of fish is $1 a pound. Now to get marginal revenue, you just have to calculate, right, how much more revenue did this boat bring. So for example, this one will be 400 because before the first boat there was zero revenue. So now there's 400. There's the $400. So the marginal revenue here will be 400. The second one, find the difference. 800 minus 400. That is going to be 400 as well. Okay, and so we can keep going and going down, and then until we get to number 7. Right, so 7 boats. Right, by adding the seventh boat, right, there is no difference in the total revenue. Right, so the 7th boat did not add any total number of fish. Right, so we get 0 here, and by adding the 8th boat, right, the overall catch actually decreased. Now, important thing to note here. This 0 here does not mean that the 7th boat didn't catch any fish. Okay, that this just means that the 7th boat comes in and everybody's fish caught goes down. Right, we're still gonna assume that all the boats are catching some fish, just that the overall fish decreases. Right, so same thing example here. When the 8th boat comes in, negative 100. This means that because of the 8th boat, the overall catch went down by 100. But this does not mean that the 8th boat catches negative 100 pound of fish or $100 worth of fish. Okay. Now total cost is a little bit straightforward. The marginal cost is constant at $260 per boat. So all you have to do is multiply $260 by the number of boats. Okay. And so you just multiply it, and that's what you will get. Okay. Oh, by the way, coming back to marginal revenue, what you can see here is clearly, so from first boat to 4th boat, that we have constant return. When we get 5, 6, and 7, we have a diminishing return. Right, and then 8th boat, we have absolutely diminishing return. Now to get marginal cost, you can find the difference between the total cost, but we don't need to do that. They're all going to be 260 because that's our assumption. Marginal cost is constant at $260. To get total profit, we just take total revenue minus total cost, and then we can get total profit here. So from here, right, we have everything laid out. Then we can clearly see then what should be the socially economically efficient allocation. Okay, in another word, as a community, what is the optimal number of fishing boats for this fishery? That would be 5 boats because at 5 boats, total profit is maximized. Okay, now maybe something, a lot of times you're not going to have total profit, right? A total profit all calculated and laid out like this. So then how else could you tell? Well, we want to focus on the condition that will allow us to state that the total profit is maximized. How do I know total profit is maximized here? Well, because marginal revenue equals marginal cost. This is, if you remember from chapter 3, the optimal condition. Okay, so here I have a graph here. It is not on your handout, but you can download it from the PowerPoint slides. Right? What we are looking for, total profit, is what we're looking for is the largest difference between total revenue and total cost, right? And now what level is going to give us that, what condition is going to give us that? That is going to be marginal revenue equals marginal cost. Okay, and so if you're looking for where the optimal level is, just compare the two you want to find where they're equal. And if you look at marginal revenue, there's going to be 300 here. You look at marginal cost, 260 here, and you say, well, wait a minute, that's not equal. All right, but then if you look at the next one, right, you notice that they cross over. You notice that they cross over. What do I mean by that? So here's 400 is greater than 260, 300 greater than 60, and then now 200 less than 260. Okay, so somewhere in the middle here is where you would find marginal revenue equals marginal cost. Now, of course, we're talking about the number of boats. You can't have 5.5 boats. So let's be a little flexible here. We're going to say 5 boats is the optimal number of boats. Right? Graphically, you can see that the optimal, the highest point, is not at 5 actually, but it's a little bit beyond 5. Okay, right. So marginal revenue, and when marginal revenue equals marginal cost, that will be the optimal. That will be the optimal number of boats. And why is it optimal? Because that will maximize our total profit for the fishery. Okay. All right. So for the fishing community, total welfare is maximized at 5 boats. But this is an open access problem. So then with no regulation, how many boats will enter the fishery? In other words, what is the open access equilibrium? How do we figure that out? Well, we focus on what is the incentive for boats to enter the fishery in the first place.